Use the definition to find the derivative of f of x equals 1 over x. Then evaluate f prime of 2. First thing to do is write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. The next thing to do is to formulate what f of x plus h is. That means to take f of x, which is 1 over x, and replace the x with x plus h, which just means we will have 1 over, instead of x, x plus h. Then we subtract from that f of x, which is 1 over x, and on all of this over h. This will be the 0 over 0 indeterminate form right now, and it will continue to be the 0 over 0 indeterminate form until we can get an h to factor in the numerator and cancel with that h that's in the denominator. Now, in order to get an h to factor in the numerator, we have fractions, and the 0 over 0 indeterminate form with fractions makes use of the common denominator method. So what we're going to do with this is multiply the two fractions to get a common denominator. What we have in the denominator right now is an x plus h in the one fraction and an x in the other fraction. The common denominator is always done by multiplication, never by addition. So we have to multiply the two. We need an x times an x plus h. So I'm going to take that first fraction, 1 over x plus h, and I'm going to multiply it by x over x. And I'm going to take that second fraction, which is 1 over x, and multiply it by x plus h over x plus h. So we have a common denominator. All this over h. Once we have the common denominator, we can combine the fractions together. Multiplying the first two fractions, 1 times x, multiplying the numerator, gives me an x. X times x plus h. Don't distribute the denominator. We always keep it factored. They are multiplying each other. And then we have minus 1 times x plus h, which is x plus h, and then the denominator will also be x times x plus h. We don't want to distribute or FOIL denominators. We keep it factored. So now f prime of x equals 2. We can subtract those fractions now that they're over a common denominator. We have limit as h goes to 0 of x minus x. Make sure to distribute the minus sign. That minus sign affects both those terms right there. So it's going to be minus x and also minus h. It's a little thing to watch out for in math. And then divided by x times x plus h, and all of this over an h. We can now combine any like terms in the numerator. The positive x and the negative x will cancel each other out. And that will give us limit as h goes to 0 of negative h over x times x plus h, and all of that over h. Once you've accomplished the common denominator, we will still have 0 over 0. That hasn't changed, but we can take the denominator fraction, reciprocate, and multiply. Well, the denominator right now is not a fraction, it's just an h, but we can make it a fraction by putting it over 1. And we want to reciprocate that and multiply it, so we will have a negative h over x times x plus h times the reciprocal of h over 1, which is 1 over h, and we're going to multiply those with each other. It's always how you handle the 0 over 0 indeterminate form resulting from a fraction. Multiply the numerators, that'll just give us a negative h. Multiplying the denominators, I will have an x. I will write the h next, and then an x plus h. They're all multiplying each other. Since they're all multiplying, the h in the denominator can cancel with the h in the numerator, leaving a negative 1 in the numerator. We have finally canceled the h in the denominator. That was our goal. I'll just rewrite what we have left once we've done that, and now we can plug a 0 in for any remaining h's because we no longer have the 0 over 0 indeterminate form. Instead, I get negative 1 over x times an x, which is a negative 1 over x squared. There's our derivative. So our f prime of x is negative 1 over x squared. And the other thing being asked for is to find f prime of 2, which simply means to plug a 2 in for the x. So we have negative 1 over 2 squared. 2 squared is 4, so we get a negative 1 over 4.